Yes. Bismillahirrahmanirrahim. Okay. Kinetic theory of gases. Everyone should have this book in front of you and come to page number 612, 612. Come to page number 612. Okay. So every material is composed of molecules. We already know that, right? Every material is composed of molecules. Heat is a form of energy and it is related to the motion of the molecule of the material. This is true, okay? Whenever we say the heat energy of a body is high, that what we mean by that? We mean that the kinetic energy of the molecule of that body is higher. Do you understand my point? The kinetic energy of that body is higher, okay? Now let us think about this way. In solid material, what happens? The molecules are tightly attached to each other, right? So as a result, they cannot move so much, okay? So their kinetic energy is less. Heat energy is also less in case of solid. Now when we convert to liquid, what we do? We supply some heat energy, right? And as a result, using the heat energy, the kinetic energy of the molecules increases, right? So when the kinetic energy increases, the substance is converted to liquid, right? So in case of liquid, the kinetic energy is higher, and also we can say the heat energy is also higher in case of liquid, and it will be highest in case of gas, okay? Because from liquid, if you want to convert to gas, you need to supply more heat energy, and that heat energy will result in increase of kinetic energy of the molecules, right? And as we know, in the gaseous state, the molecules have highest kinetic energy, right? They are in random motion. This random motion is actually known as Brownian motion. I hope you studied this in chemistry. I remember I studied, okay? So yeah, so heat energy is directly related to the kinetic energy, okay? The more heat energy, the more kinetic energy of the molecule, okay? So this is actually the main basic of kinetic theory of gas. Achha? So let us go through the second line. The molecule of a material are always in motion, right? The molecules of gaseous material almost independently can move in a confined space. That means between the molecules there is no attraction or repulsion force, right? Independent. They are independent. They are not under influence of any other molecule. But in case of solid and liquid, there is some attraction force, and due to this attraction force, they cannot move independently actually, okay? So they are under influence of some other attraction and repulsion force exerted by the other molecule. But in case of gaseous, no such case, okay? Everyone can move any direction as it wants, okay? Achha. Now, the theory that is evolved to get the laws of behavior of the gaseous material is known as kinetic theory of gases, okay? The fundamental thing about kinetic theory is that due to thermal agitation, the molecules of gases are in random agitation. Yes, thermal agitation. That means we supply heat energy, and due to that, they are in random motion. Okay? Achha. The average kinetic energy of a gas is directly proportional to its absolute temperature. Right? If we rise the temperature, how we rise the temperature? We supply heat energy, and if we supply the heat energy, definitely it will increase the average kinetic energy of the gas, right? Now, what do we mean by average kinetic energy? There is kinetic energy for all the particles, right? We take the summation of all the particles divided by number of particles. That will give me the average. This is the way to find the average, right? So average kinetic energy is directly proportional to the absolute temperature. That means you double the absolute temperature, you double the average kinetic energy. You triple the temperature, the average kinetic energy will be tripled of the gas. Okay, they are directly proportional. Achha. Please, these are the lines you should be marking. Okay, if you have a highlighter, mark this kind of lines because these are important for MCQs. With the increase of temperature, the average kinetic energy of gases increases. This is what we just studied, right? When heat is taken away from a gas, okay, now we are reducing the heat. The heat is being taken away. So how we do that? By reducing the temperature. We reduce the temperature, we take away the heat. We are taking away the energy. So they will lose energy, and now they will have less amount of kinetic energy, right? As they have less amount of energy, they will be moving with less amount of velocity. Less velocity means less kinetic energy. You understand this, right? We raise the temperature, we supply the heat energy, their average kinetic energy increase because they have more energy now. I take out the energy, now they will move, slower.
স্যার
Go on.
absolute temperature কি?
Absolute temperature is the Kelvin scale temperature. If you remember, while studying Charles' law, we saw this graph. Okay, at minus 273 degrees Celsius, the volume becomes zero, right? Okay, behind that we cannot imagine any temperature. This is the least amount of temperature that we can imagine, because after that the volume becomes negative. The volume cannot be negative. So considering this one as zero, we start a new type of scale of temperature, that is Kelvin temperature. See, this is 0 is equal to minus 273. So at 0 degrees Celsius, it is 273 Kelvin. If I start from 0 here, definitely it will be 273 Kelvin. Remember, we studied this one, then 1 degree Celsius is 274 Kelvin. Okay, 2 degrees Celsius, 275 Kelvin. So this is the absolute value of temperature. Kelvin temperature is the absolute value of temperature. Why absolute? Because this one can never be negative, because we cannot imagine any temperature behind this. Okay, so this is 0, we cannot go behind 0. So the value of this type of temperature will always going to be positive. So if it is, we are having positive value only, then this is the absolute value, right? মনে পড়ছে কি ছিলা ওই ক্লাসে?
হ্যাঁ স্যার ছিলাম, বুঝছি আমি এখন।
So this is, we are talking about, as I told you, if I write theta, I am mentioning degree Celsius. Okay, I am referring to the temperature in degree Celsius. But if I write capital T, then I am indicating the unit Kelvin. Okay, so yes, this is the absolute temperature, and this proportional to this one. Okay, absolute temperature. Achha, now when heat is taken away from gas, then the average kinetic energy of the molecule reduces. This is what we understand, right? So at absolute zero temperature, the kinetic energy will be zero, right? Okay, we reduce the temperature, kinetic energy decreases, reduce the temperature, kinetic energy decreases. So if we continue the reducing process, what will happen? We reduce the temperature, and we come to zero temperature, 0 Kelvin. Okay, 0 Kelvin. At this state, actually all the molecules will lose all its kinetic energy. Okay, and as a result, the velocity will become 0. This is what happens theoretically. Okay, not practically. In practical, actually what happens when you approach 0 Kelvin temperature, that means from 0 degree Celsius, if you come back, what will happen? That a gas will be converted to liquid. Actually, before we attain this temperature, the gaseous material is converted to liquid and to solid. Okay, if you reduce the temperature, we know that this is the condensation process, that you reduce the temperature of a gaseous material, what will happen? It will be converted to liquid at some point, and still if you keep reducing the temperature, it will be converted to solid at one point. If you think about water vapor, water and ice. Okay, you reduce the temperature of water vapor, it will be converted to liquid, and subsequently it will be converted to ice. Somebody sent a message, sir absolute temperature ki? Acha, ওটা তুমি মেসেজে জিজ্ঞেস করো।
আমি আগে আজ করছি।
Okay, so now let us continue. So at absolute zero temperature, the kinetic energy is 0. It means at absolute zero temperature, the molecules of gas come to rest. No kinetic energy means they come to rest. Okay, and they will have no kinetic energy. Okay, fine. But before attaining the absolute temperature, every gas changes to liquid state or solid state. The kinetic theory of gas can explain the behaviors of gases like diffusion, osmosis, evaporation, vapor pressure, expansion of gas, Brownian motion, etc. You all have gone through all these processes, right? Diffusion process and osmosis process. I think this one you studied. Diffusion you studied in chemistry, and osmosis you studied in biology. You did some practical also, right? Using the potato. Did you? You are supposed to do that experiment. Okay. Evaporation also you know. Acha, Brownian motion I just explained. Okay, we get the direct proof of kinetic theory of gases from Brownian motion. Okay, the molecule of a gas, those obey the basic assumption of the kinetic theory at any temperature and pressure, no matter irrespective of the temperature and pressure. At every temperature and pressure, it will maintain the kinetic theory. Okay, those gases are called ideal gases, which does not exist in practical. Okay, So yeah, but behaves according to the laws obtained from the assumptions is called ideal gas. In fact, no gas behaves like an ideal gas. It's only an imagination. Still, we get idea about the behavior of real gas from all the laws of ideal gas, right? Real gas are the gas which exist in real. Okay, those are the real gas, and we always compare which real gas is more closer to the ideal one. Okay, acha. Now the next topic that we have is mean velocity. Mean means average, right? So velocity, average of the velocity is mean velocity. This is very simple to understand, I feel. জহিরুল তো অলরেডি আছে দেখা যাচ্ছে। এই যে জহিরুল আছে তো, জহিরুল সবার আগে জয়েন করছে মনে হয়। গ্রুপে আছে। হ্যাঁ গ্রুপে আছে, গ্রুপে না মেবি জামানোকে ইনফর্ম করে। আচ্ছা, তারপরে mean velocity. Acha. Mean velocity is, let us say there are several molecules, right? C1 is the velocity of the first molecule, C2 is the velocity of the second molecule, okay, C3 is the velocity of the third molecule. Likewise, I will go up to, let us say n number of molecules are there, so I will go up to n. And if I want to find the average of them, I will take the summation of all of them divided by n. N number of molecules are there, right? So divided by n. This is actually what we call mean velocity. Okay. After the mean velocity, we will have mean square velocity. Mean square velocity. Now, mean square velocity means, you know, always come from the right side. Okay. Right side থেকে আসবা. So right side থেকে আসলে at first we see velocity, right? So velocity মানে কি C1, C2, C3 up to Cn. Velocity পরে আসতেছে কি square. Okay, so square দিয়ে প্রত্যেকটার উপরে. Okay, then mean মানে হচ্ছে divided by n. So right side থেকে পড়ে পড়ে যদি আসো, then it becomes very easier to understand. Okay, so this is mean square velocity. Okay, then there is root mean square velocity. Root mean square velocity, RMS. I have a space here, I will show you. RMS, it is given in your book. আচ্ছা, তোমাদের বইতে একটা জিনিস ভুল লেখা আছে দেখলাম। See, mean square velocity এটার পাশেই লেখা আছে RMS velocity. Mean square velocity is not RMS. The next one, root mean square velocity, that is RMS. Okay, so kindly make the necessary change. I will show you. Wait. If you see here, mean square velocity, here it is written RMS velocity. This is not right. This is the mean square velocity or RMS velocity. Okay, this is right. This is not RMS velocity. So kindly cut it and make the necessary change. Okay, acha. So then we will be studying root mean square velocity. Okay, as I told you, come from the right side. Velocity, you will take the velocity first. C1, C2, C3, C4, and we will continue up to Cn, right? Velocity we have taken, then square. So we will take a square. Okay, then we will take a square. After that, mean. We will take mean. Mean means সবগুলো plus, okay, divided by n, number of molecule, right? Then we have root. So we will give a big root over all of it. Understood this one? So this is root mean square velocity. We will take the velocity first, we will do the square, then we will take the mean, and then we will do the root over. So this is the root mean square velocity. Is there any problem in understanding? If anybody has any doubt, you can ask me. Okay, nobody is asking any question. So these are the three types of velocities. Okay, mean velocity, mean square velocity, root mean square velocity. Okay, very important for exam. Okay, yeah, most probable velocity is just an idea, no actually calculation or equation is there. Most probable velocity is, let us say I can say that there is 10 molecule in a what do I say, in a gas. 10 molecules are there. Out of 10, 7 molecules are having a velocity of 5 meter per second. okay, and two molecules are having a velocity of 3 meter per second, and one molecule is having a velocity of 7 meter per second. Okay, these are just assumption. So from here, if I ask you, most of the molecules are having which velocity? 5 meter per second. Most of the molecules are having this velocity, right? So this is the most probable velocity of that gas. Most of the molecules, or the highest number of molecules, are having this velocity. So this is the most probable velocity of that gas. It is written in the definition. If you notice, go through the definition. The velocity at which most of the molecules of a gas are in motion, that is the most probable velocity of that gas. Most of the molecules, okay, majority of the molecules. So we can see it here. Acha. Now we come to the biggest derivation that you are ever going to study in this level. Okay, but the good news I already gave you, that you do not have to memorize the derivation. Okay, in our time actually it was important, because that time it was not creative system. This type of question used to come for 5-6 marks. Okay, now the maximum mark you have is 4, and all there also it is mathematical analysis, based on mathematical analysis. Okay, derivations are not necessary for you anymore. So for numerical problems, mathematical analysis, you need to keep in your mind the equations. Okay, but you will be able to use the equations successfully only when you understand the derivation properly. Okay, so please pay your highest attention. Just try to understand, no need to memorize. Do not take the pressure of memorizing. Now let us draw the figure that is given here first. Figure 10.7. 10.7. Achha, this is a 3D figure. Okay, you can consider this one as one corner of your room. Okay, as I showed you, 3-dimensional system, corner of your room, 3 axis goes in 3 direction. So that this is the corner of the room. Okay, and at the corner of the room you have placed a box. I am very bad at drawing this type of I hope you can imagine that there is a box that is kept at the corner of your room, right? Okay, it looks like that. Okay, so this is a wall. Okay, this is a wall of the box. One wall of the box, and the opposite wall of the box is this. Okay, now it is imaginable. Okay, two wall of the box. Let us say this wall of the box is considered as A, and this one is A prime. Okay, and these 3 axes are X, this one is Y, and this is Z. Achha. Now let a gas is confined in a cubic container. Cubic container means a box or a container that has same length, breadth, and height. Cube. Okay, I hope you know what cube means. Okay, have you ever solved Rubik's cube? Rubik's cube, different type of colors are there, and you have to match the color. Okay, in one surface there should be only red, another surface it should be green. Rubik's cube, many of you have solved. You will notice the Rubik's cube is always are having same length, breadth, and height. Okay, it is never a rectangle, because it is cube, right? Cube are having same length, breadth, and height. Okay, acha. Now the wall of the container is perfectly elastic. Perfectly elastic. What we mean by perfectly elastic? I explained this one yesterday. Okay, there will be no loss of kinetic energy whenever the molecule comes into collision or experiences a collision with the wall. Okay, no loss of kinetic energy. Achha. Now let L be the length of each side of container. Okay, that means length is L, breadth is also L, and height is also L. That means this length. This is L, this is L, and from here, this is also L. Okay, length, breadth, height, all are L. Achha. So L cube will be the volume, length into breadth into height. Okay, that is the volume. So volume is equal to L cube. Acha, that is equal to V, volume V. Now m is the mass of each molecule. Okay, so the mass of one molecule is small m. So for one molecule it is m. For n number of molecule it is going to be nm, right? So this is the mass of only one molecule. This is the mass of all the molecules. So the mass of all molecule is equal to the total mass of the gas, right? If I take all the mass of the all molecules, then I will get the total mass of the gas, right? So this is what this is. Mass of one molecule, the mass of all the molecules. So all the molecules mass is equal to the total mass of the gas. I hope you understand. Now let us first consider one molecule who is moving along x-axis. X-axis is along this direction, right? So inside the container there is a molecule. Let us say this is a molecule which is moving along x-axis. Along x-axis means this x-axis, okay? And towards the wall A of the container. This is the wall A of the container, right? Okay, so it is moving towards that wall. So if it is moving towards that wall, there will be a time when it will experience a collision with the wall, right? So we will see what happens. Okay, towards the wall A of the with velocity u1. Okay, u1 is the velocity of that particular body. Achha, okay. Then what we have, so the molecules collide with the wall A perpendicular to the x-axis. Yes, this wall A is perpendicular, right? If you notice, this wall is perpendicular to x-axis. Achha. Since the collision is completely elastic, the molecule will move in the opposite direction with velocity minus u1. Correct? Okay. Elastic. That means no loss of kinetic energy will be experienced. So if there is no loss of kinetic energy, then what will happen? Then there won't be any decrease in velocity. Correct? The velocity was u1, still it will be u1. Okay, just in the opposite direction. As it is in the opposite direction, so now the velocity will be minus u1. That means the molecule was traveling in this direction, it collided with the wall and it bounced back with the same velocity. With the same velocity. This is what elastic means. No velocity change will occur here. Understood? Okay. Achha. So then what is happening? So the molecules collide with the wall A perpendicular to the problem. Then completely elastic. The molecule will move in the opposite direction with velocity u1. Due to this collision, change of momentum. Achha, let's try to find out the change of momentum, right? How to find the change of momentum? See, to find the change of momentum, we need the final momentum and initial momentum. Then only we can find the change of momentum, right? So if this is the initial velocity, the initial momentum is going to be mu1. We know that one molecule is having mass of m. So mass into velocity, that is the momentum, right? So this is initial momentum and this is the final momentum, right? Minus mu1. Minus mu1. Why? Because u1 is minus here, right? So this is the final momentum, this is the initial momentum. If I tell you to find out the change of momentum from here, change of momentum from here, then what you will do? You will write final momentum minus initial momentum. This is the way to find out the change, right? Final take initial to minus. So final momentum is which one? Minus mu1 minus the initial momentum is mu1. Okay, so what will happen? Minus 2 mu1. This is the amount of change of momentum which is directly written here. I hope you understand. Okay, so due to this collision, the change of momentum of the molecule perpendicular to the wall A is minus 2 mu1. Okay, now as we know, the conservation law of momentum is being applied here. You can see that there has been a decrease of momentum in the molecule, right? So as there is a decrease of momentum in the molecule, there must be an increase of momentum in the wall. As a result, they will be what? Balancing each other. So as a result, total momentum will be same. Okay. That means if the change of momentum for the molecule is minus 2 mu1, the change of momentum for the wall will be 2 mu1 plus 2 mu1. Okay. So minus 2 mu1 plus 2 mu1, they will balance each other and it will be 0 again. Okay, so they will balance each other. This is what they have written. According to the law of conservation of momentum, the molecule will apply same and opposite momentum to mu1 on the wall. That means due to the collision, the change of momentum of the wall will be to mu1. Okay, I hope you understand. If I'm going too fast, kindly let me know, then I will try to slow down a little bit. Okay. Acha. Now let this change of momentum takes place in time t. Okay, that is the time of collision actually. Okay, when the time collision takes place, that is the time of change of momentum, because due to the collision, the momentum change takes place. Okay, I hope till now it is clear. Okay, so I can erase. Acha, change of momentum. Okay, it ekটু রাখি. Okay, now t is the time. Okay, so if this is the change of momentum, change of momentum is equal to minus 2m u1. And if I tell you to find out the rate of change of momentum, all you need to do is divided by time t. Right? We already studied this one before. Whenever we are talking about rate of something, we are dividing that quantity by t, right? So this is there. Acha. Now, if you notice, t is equal to what we can write. আচ্ছা, t টাকে আরো অনেক কিছু ধরা হয়েছে, দেখো তো। t is the time between two successive collision. Okay, if I take time t as time between two successive collision, means from a it will start the journey. Okay, so it will come to the wall a prime, it will experience one collision. Do you understand? Then again it will come back here, right? Again it will experience one collision. So the time taken between these two collision is t. So in this time it will travel from a to a prime, l distance, and then again from a prime to a it will come again another l distance. So the distance covered by it will be distance. If I write distance is equal to 2l, the time taken is t, t is equal to t, and the velocity we have considered to be u1, right? Now as you know, velocity is equal to distance by time. We are not considering any kind of acceleration here. Please remember this one. Okay, and if there is no acceleration, if you remember in grade 10 I told you several times, whenever there is uniform velocity, we apply this s equal to vt equation. So s equal to vt means, you know, this t, if I change the side, it will become like this: velocity equal to distance by time. This is what I have written here. Now here the distance covered is 2l and divided by time is t. So u1 is equal to 2l by t. From here t is equal to, I can write 2l divided by u1. Can I write this? T is equal to 2l by u1. I can write. Okay. Then so the rate of change of momentum is this one. Okay. The molecule, oh, the rate of change of momentum of the wall we are talking about. If you notice, the rate of change of momentum of the wall we are talking about, for the wall it is positive 2 mu1, right? The rate of change of momentum of the wall will be 2 mu1 by t. So if I replace the value of t here, then how it will be? Two mu1 divided by t will be replaced by 2 by u1. 2 by t. The 2 and 2 will be cancelled. It will be m u1 square by l. Right? M u1 square by l. Okay, so this is the rate of change of momentum. But from Newton's second law, what we get? The rate of change of momentum is equal to the applied force. So this is the rate of change of momentum. This is equal to the applied force. So I can say the applied force F is equal to m u1 square by l. Okay, so this is the applied force. Anybody has any doubt till now? From here I will try to find out the pressure. Okay, from force, if I try to find out the pressure P is equal to F divided by A, correct? So F, we have mu1 square by L, okay, divided, this is L. Now we will place A, area. What will be the area of the wall? Can anybody tell me what will be the area of the wall?
L cube. No,
Cube is volume.
volume. L.
Area.
A square.
A square means
A.
L square.
L. Okay.
See, four sides.
Four
L,
sides.
L. This is a square, right? So side square. Okay. So the area will be L square. So from here, what I can write? mu1 square divided by L into 1 by L square. Okay. If I make this division into multiplication, then it will be reversed, 1 by L square. So it will become equal to mu1 square divided by L cube. Correct? We have come to page number 615. See, this is the pressure on the wall. Okay, we have found out the pressure on the wall. Okay. So as you can see, if there are total n number of molecules in the container, then their velocities along x will be u1, u2, right? We have till now we have considered only for one molecule, that is u1, right? If there is another molecule, we will consider that u2, another one u3. Likewise, n number of molecules are there, we have considered. So un will be the velocity of n number of molecule along x-axis. All these u1, u2 are along x-axis. Okay. So this is what they have written. If there are total n number of molecules in the container, then their velocities along x-axis will be respectively u1, u2 up to un. Then the total pressure on the wall. See, this is the pressure. This is the pressure exerted by only one molecule. If I consider it for all the molecules, then all the pressure I have to add, right? How I will add? Total pressure on the wall. So what I will do, I will write the first pressure for the first molecule, mu1 square by L cube, then pressure for the second molecule, okay, then the pressure for the third molecule. Likewise, I will continue mu1 square divided by L cube, right? So from here, m by L cube, I can take m by L cube common, right? M by L cube, so it will become u1 square plus u2 square plus u3 square plus up to un square. Okay, they have skipped this line, so if you have any problem, they have directly written this line. Okay, so if you find any difficulty in understanding this problem, just take a look at this problem, this line. Okay, I think you should be writing this line in your book if you have a little space. And if you write it, then later it won't cause any confusion. Okay. Achha. So after that, now if the mean square velocity we are talking about, right? Mean square velocity means mean square. So square comes first. Square, then we will put mean. Kindly be very careful while writing. I will tell you again. Okay, I have seen students making mistake, so I will inform you what are the mistake made by the student. Mean square velocity, that means I will come from right side, so square has to be done first. Okay, let us say u. Okay, square has to be done first, then I have to take mean. Do you understand? Many people write it in this way. They give the mean first, then give the square. So this is wrong. Okay, this means square mean velocity. Okay, mean you have done first, then you have taken a square. So both of them mean different thing. This is you have to write. Okay, this is correct. Please take note. Okay, square you have to do first, then mean. Okay, I hope you understand. Achha. So this one will be equal to u1 square plus u2 square plus up to un square divided by number of molecule, right? We have taken square and then we have taken the mean. So from here, if I cross multiply, n will come in this side and n u square bar will be equal to un square plus u2 square plus up to un square. Okay. Now you see, I can replace the value of this part. Replace the value of this part. I have got the value of this one as nu square, right? So if I replace it here, then what it will become? You see, this is the pressure, right? Total pressure. So total pressure is equal to, I will write m by L cube. This one will be replaced by nu square. Nu square bar. I can write it like. Till now, anybody has any doubt? Ask me questions because I'm going to erase this part and write the next.